And welcome spaced out viewers to the Daily Space Weather Show. If you're looking for the in-depth information about the closest star, well, you've come to the right place. We've got, looks like some high-energy particles there striking the Proba 2 spacecraft, which is what you're viewing there. That's the Proba 2 mission, about a 24-hour video there. And today we've even got a cosmic ray report. So lots to cover today at the Smash News Network, least busted name in news. Let's get to it. That is 174 angstroms from the Proba 2's SWAP instrument. And you might see one coronal mass ejection there. There was an M-class flare as well. It came from the northeastern limb, which is exactly where a couple days ago we were talking about the northeastern limb. In fact, you could even see me pointing to it on a thumbnail from a couple days ago. We do have two significant solar flare players on the Earth-facing portion of the solar disk. Here's the equatorial view. And there do appear to be two more active regions rising there behind the eastern limb, one in the northeast and one in the southeast. The one in the northeast looks like it might be a major sunspot. It has a lot of suspended plasma associated with it. You can see huge loops of material up there in the northeast. So expecting the rising of a new sunspot here in a day or two. We've also got a massive number of plasma filaments, which we will show you in amazing detail, as we are known to do on the channel. So just up and to the right of our Earth scale there, that is the one of two large solar flare players going forward. We do have a coronal mass ejection on the way as well. We're expecting one to arrive late in the day tomorrow or early on the day October 5th. So see yesterday's video if you want to see analysis of that. And by the way, don't forget to press the like button. Yeah, press the like button. If you're new to the channel, press the subscribe button. Do yourself a favor and get the most comprehensive daily space weather content in the known universe straight on your YouTube subscription feed. Not only that, you'll also see the most detailed imagery anywhere of the closest star. The best stargazing is looking at the closest one, as it is plenty interesting. We also do throw in meteorology segments and various bonus features. Again, today we'll be doing a cosmic ray feature. We'll be given the cosmic ray report. So why not press the like button? No, that's okay. We'll wait. Have you pressed the like button yet? If you don't press like, we will find you and we will shame you. Just kidding, folks. In all seriousness, thanks to our new YouTube subscribers. Here's the SDO intensity gram for the past about 35 hours. That's yesterday plus today, October 2nd and October 3rd to date. No major changes happening there, it looks like. Most of those sunspots have been pretty stable for the past 24 hours. Here's the colorized magnetogram to reinforce this fact. And we'll show more close-up imagery of sunspots and so forth here momentarily. First, we've got some new volcanoes on the list. There's the world's most delicious-sounding volcano, Stromboli. Some thermal imagery of that. Another new lava flow there, cascading down the Sierra del Fuoco at Stromboli. Campi Flegrei. Seismic swarm occurring below Campi Flegrei. So perhaps a possibility of an eruption coming there. Mount Mayon producing an unknown volcanic ash plume. It is erupting on Luzon Island, Philippines. Here's another one. We've never heard of this one before. Slamet on central Java, Indonesia. showing some ground deformation there, although not at the summit. So maybe we're going to see some lava pop out of the side of the slope of that one. Ground deformation there at 1,500 meters above sea level, but not at 2,000 meters above sea level. So a little lump developing on the side of that Slamet volcano slope. Also, passive emissions of steam and gas continue to emit from the crater vent. Semeru on East Java producing a 17,000-foot plume of volcanic ash. Flight level 170, flight level 050 over Katmai on the Alaskan Peninsula as it explodes. Katmai there. The Alaskan Peninsula volcano. Shishildin also produced a 13th paroxysm there. No indication on the ash plume from that. However, lava fountains continue to eject juvenile, fresh, and plastic lava fragments, in turn leading to incandescent rockfall avalanches as they land on the slope of the edifice. Shishildin erupting. Fuego in Guatemala mildly exploding. No indication on the ash plume there over Guatemala from Fuego. However, Nevado del Ruiz in Colombia producing a 21,000-foot ash plume. It's a flight level 210. Same thing over Ecuador. Sangay exploding, flight level 210. 21,000-foot ash plume. 14,000-foot ash plume over Ecuador from Revenador as it explodes. It's a flight level 140. Flight level 210 over Sabancaya in Peru. 21,000-foot ash plume. And let's get to seismic activity. We saw some interesting seismic activity happening here around the Indo-Asian plate boundary. We'll get to it. There are the past 90 days of seismic activity, and these are the quakes of a 5 or greater magnitude. So quakes around India and Tajikistan here, starting out with this 5.4 that occurred yesterday at 12:45 Universal Time. A 5.4 there, right on the Indo-Asian plate boundary. Then, about an hour and a half later, a 5.3 strikes Tajikistan, well to the northwest of that. And then no 5 or greater magnitude quakes for an extended period until the largest quake of the past 24 happens in the Western Pacific. A 5.7 at Papua New Guinea occurred at 1:56 this morning on October 3rd. 5.7 at Papua New Guinea. And then last but not least, Nepal at 9:21 Universal Time this morning. So the seismic unrest continues over there at the Indo-Asian plate boundary. Just remember, folks, any earthquake can be a foreshock. That ends our list of 5 or greater magnitude quakes. And let's take a look at filaments here. So there's the 304 angstroms wavelength from SDO. And I would especially note this filament right here. This filament right here is pretty berserk. It is absolutely gigantic. And fingers crossed that that one erupts, as that could create some great space weather at Earth. That one is deserving of a name as well. You've got an active region just to its left, which would be to its east, and as well as another active region to its south. So certainly a high capability of that one to eject, with the 2 most likely flare-producing sunspots right nearby. We've also got the 171 angstroms wavelength. It's the house favorite. There you go. That's what I'm talking about. Once again, this is October 2nd and October 3rd to date. So that's the scenario. Let's take a look at some stats. The 10.7 centimeter radial flux has dipped a little bit to 158 solar flux units. The 10.7 centimeter radial flux is super important. It's very similar to sunspot number. And from this 1-year chart, you can see how directly proportional those 2 features indeed are. Notice the correlation between the red and black lines. The red line being the sunspot number, the black line being the 10.7 centimeter radial flux. 158 solar flux units is the new radial flux number For today, a mild decrease from yesterday. Space weather enthusiast dashboard now not forecasting any geomagnetic unrest. We've already passed that forecast of a KP4 earlier this morning. We never saw a KP4. We have not seen a coronal hole high-speed stream show up. I suspect it's probably late, but it is going to show up. So I don't know why NOAA forecasted it so early. But I would expect to see a coronal hole high-speed stream here, a rather short-lasting one, in a couple of days. Now, as far as their NOAA's Enlil spiral, they have not modeled the CME that we talked about yesterday. We are expecting this CME to arrive sometime around this time, late in the day tomorrow on October 4th, or early in the day October 5th. It'll be minor. We won't see anything higher than about a KP6 at the most. It was pretty diffuse, but it was quite earthly directed. So, sometime around here, we are expecting a little uptick there from a minor coronal mass ejection impact. It was fairly stealthy, and I think we're the only ones who caught it. NASA did not catch it either. There's NASA's Enlil spiral, and it has not been updated for quite a while here, so let's move on to Earth's magnetic moment from space. Now, you're going to see an uptick in the magnetohydrodynamic pressure here. This is our geospace magnetosphere movie depicting the past 4 hours, and this uptick is probably not a real uptick, as there are two instruments, and that is an instrument switch. So when the active spacecraft switches from one to the other, they're often measuring different solar wind parameters, and that's what's happened there. That's the past 4 hours of Earth's magnetic moment from space, allegedly, according to the space weather modeling framework. You'll also see an uptick in the ground magnetic perturbations map here. This also depicts the past 4 hours, because, again, the spacecraft, the active spacecraft, recently switched, and the different spacecraft at Lagrangian point 1 are going to be measuring different solar wind parameters. So that's that minor uptick. That is not really a space weather uptick. Planetary K-index at 1.66, 1.6 really, which is rounded to 1.67. And if you're new to the channel, the planetary K-index is an average of global geomagnetism. Calm conditions, very calm at the moment. So here's this switch that I was talking about. Here is the ACE spacecraft and then the Discover. So this is just an example of very different solar wind parameters at two different spacecraft orbiting the same location. So you've got two different spacecraft out at Lagrangian point 1, a million miles from the Earth, and one of them might be seeing a completely different plasma environment than the other one. There might be a higher speed wind over here than this one. There might be a lower speed over here. There might be a higher density, lower density. Because, folks, the material that comes out of the sun is extremely filamentary in nature. You can have strings of material. Lagrange point 1 is kind of large. So those spacecraft are orbiting that Lagrangian point. And in doing so, they may be getting very different solar wind parameters. That's what you see happening here on this imagery. On this data, rather. So a prime example here of 440 kilometers per second measured by the Discover, and only 334 kilometers per second measured by the ACE. So here it went from the Discover to the ACE and now back to the Discover again. That's what you were seeing with those little upticks in the geospace magnetosphere movie and the ground magnetic perturbations map. Current conditions as reported by the Discover are a little bit elevated here at 482 kilometers per second for the solar wind speed. Solar wind density here about 7 protons per cubic centimeter. Those are fairly nominal. That could be a weak coronal hole high-speed stream. Unfortunately, we didn't really see a very good signal there. Let's just briefly switch to just the Discover to see if we see a signal from a coronal hole high-speed stream. And it doesn't really look like it. I mean, if the density only made it up to 5 protons per cubic centimeter, that doesn't look like a legit coronal hole high-speed stream. Anyway, we'll switch back to the active spacecraft. That's the real-time solar wind, by the way, part of the Space Weather Prediction Center if you want to follow that yourself. And next, the GOES magnetometers. So the GOES magnetometers, those are located at geosynchronous near equatorial orbits. They orbit Earth at about 23,500 miles of altitude, way out in the outer portion of the outer Van Allen belt. And we're seeing smooth data there, another indication that we haven't had a coronal hole high-speed stream show up yet. Next, our top view ecliptic plane field plot. Earth has just recently snapped into a South Pole current sheet, depicted there in red. The solar plasma, it is oriented to one polar field or the other. So the current regime is indeed a South Pole current sheet depicted here in red. There you go, South Pole current sheet. Earth having recently left the North Pole current sheet. Next, the solar B field depicted in blue, our line of sight field plot. Sort of gives you a holistic picture of the magnetism. Photosphere magnetism in grayscale, polar coronal magnetism there in red for north and red for south and green for north, and the solar B field, which is kind of like a net field of the two polar fields, or you could consider it the field that goes through the magnet, this magnet being the sun. Next, our line of sight field plot. And we've got South Pole oriented coronal holes here rotating in the east. So if you bring up the latest image, there you go. North Pole coronal holes rotating to the west, South Pole coronal holes rotating in the east. Here's SDO 211 angstroms. So here we've got South Pole coronal holes, and here we've got North Pole coronal holes. So that is the scenario. And next we'll cover sunspots. Sunspots, I guess they're kind of important to a solar cycle, right? Right? So let's check our flare monitor here. We'll show you that. I've already taken a look at it myself, but we want to show our viewers, and before we even do that, there's a sunspot number as reported by the Royal Observatory of Belgium. Current sunspot number at about 135 sunspots. And here is our flare monitor and flare scoreboard. The two biggest players for solar flares are certainly at the moment going to be this complex sunspot group right here and this sunspot group down here. So there is still a significant possibility of an M or even an X-class flare, especially from this northern group. It has been the most active sunspot. And let's take a look at SDO intensity gram. So it is a huge, it's actually two sunspots. That is a huge group of umbrae regardless. There has been a little degradation of this group up here. And also these sunspots have degraded a little bit. So, and indeed we do see a little downtick in the radio flux and the sunspot number. A little bit of growth of this group. So again, still a significant likelihood of large solar flares. And let's talk energetic particles and solar flares. Now, when a coronal hole high-speed stream does show up, and it's likely, we will have an increased possibility of solar energetic particle events. At the moment, no solar energetic particle events. The GOES proton flux there remains at baseline levels. As far as flaring goes, it's been minor. One happened here as we did show prep. The largest was right after our show premiered yesterday. It was an M1.5 class solar flare, and peak flux was around 1250 universal time yesterday on October 2nd. Let's take a look. Here we've paused the 94 angstroms wavelength. Let's actually zoom out there. And we put this in slow motion for your viewing pleasure. So there's that solar flare. There was a coronal mass ejection, and it was a very slow coronal mass ejection. It certainly took its good old time making its way out of the sun's atmosphere. It took the majority of the rest of the day to make its way out. In fact, early this morning it was still exiting the corona. So a very long duration coronal mass ejection. And here's a little closer view for you. Let's also show 131 angstroms. And next, let's move on to a star chart. I guess it counts as space weather. Oh, before we do that, I almost forgot. We've got a cosmic ray report to go for. So check it out. This is the cosmic ray report for October 3rd, 2023. Interestingly enough, but perhaps not surprising to our regular viewers, we've had a recent uptick in cosmic ray flux. And check it out, folks. We had a decrease right here. Looks like a 4-bush decrease right as we created the video here, just in the past half an hour maybe. Check it out. The Apatity Neutron Monitor showing a significant decrease there in cosmic rays over the past about hour. So I was about to report on an increase in cosmic ray flux at Apatity, and guess what? We've got a decrease over the past 30 days instead. So I've been countermanded there by the neutron monitor. A big decrease there at Apatity in cosmic ray flux. It was up until the last about an hour ago, and now it's down over the past 30 days. One of the most significant decreases here in the past month. Big decrease there at Apatity Neutron Monitor. What's going on at Barentsburg? Barentsburg is also ticking down. However, it is up over the past 30 days. So an increase in cosmic ray flux at Barentsburg and a decrease at Apatity. Let's go farther south to Athens. Athens showing a slight increase in cosmic rays. That's the Athens Neutron Monitor over the past 30 days. You can see these previous 2 4-bush decreases associated with geomagnetic storms. Let's go even farther south to Mexico City. Mexico City showing an uptick in cosmic rays over the past 30 days. Let's go way back up north to Oulu, Finland. What's going on at Oulu? An uptick at Oulu for the past 30 days, as you can see there. I would remind you that we are still at the lowest levels of cosmic ray flux since about 2004. So that's an indication that we are not at solar maximum. So check it out, folks. You see how long solar maximum tend to last? See that? Solar maximum, solar maximum. Cosmic ray minima are associated with solar maximum. So there you go. There are 5 of them. And you see the way it doesn't come down and goes right back up. It stays low for a while most of the time. It stays kind of low. Yeah. So you see what's going on here. Not at solar maximum. However, again, at the lowest levels since about 2004. And almost all of the monitors agree with that. So now that we've shown about 6 monitors here, let's take a look at the farthest south ones. DOMB Antarctica showing a modest uptick there. You can see both of those recent 4-bush decreases. And there's DOMC Antarctica showing practically the same chart. That's the cosmic ray report for October 3rd. Talking about the past 30 days. We cover it at least once a week on the channel. And here's what's going on overhead, by the way. We're located in Lehigh Valley, Pennsylvania. We've got Jupiter, the Moon, Venus, and Mercury all up there in the sky pre-sunrise. And if you are viewing the pre-dawn skies, you might get a great view of the third brightest object. My favorite non-Earth planet, it's Jupiter. We'll also do a star chart. A solar system forecast, rather. In addition to our star chart, that is. Here is your 1-week forecast for the solar system. That's where things will be in 7 days. And if you're spooked of these planets that are glowing purple, that simply means that they are in retrograde motion. Earth moves much faster than those planets. And so those planets, from Earth's perspective, are moving in the opposite direction to the background stars. Retrograde motion. That's all it means, folks. Retrograde motion. So the outer planets are currently in retrograde. Next, our astronomy photo of the day, which is the engraved hourglass. This is me learning to speak the English language. It's the engraved hourglass nebula. And this article is from Wiki. If you want to read about it, there's even a 3D animation of what it likely looks like there over on Wiki. Anyway, there is the hourglass nebula. What this imagery depicts, by the way, it is depicting hydrogen, nitrogen, and oxygen. So the hydrogen is this orange portion. Let's see, is it the... It says green for hydrogen, but it's actually showing it orange there. The nitrogen is the red, and the oxygen is the blue. So the oxygen's blue right there toward the core of this, believed to be a planetary nebula, actually. And then you've got nitrogen in pink, and then hydrogen, which is the majority of the gas emitted from the star there, in orange. Again, the engraved hourglass nebula, today's astronomy photo of the day. There it is at apod.nasa.gov. What an interesting nebula indeed, believed to be a white dwarf star. And it's believed to be the end stages of a sun-like star. Whether you believe that or not, I'm not too concerned. Let's take a look at coronal mass ejection, since we did have some significant activity. You will see one popping off in the northeastern limb. That would be the upper left, toward the end of the video there. Again, that CME in the northeast did take its good old time there. The solar flare was just before 1 o'clock universal time. That's 1300 universal time. And it took like another 10 hours for it to actually leave the solar corona. It was not, however, earthly directed. Let's show some more. That's 71 frames from yesterday, October 2nd. Here are additional 40 frames from today, October 3rd. You will see the tail end of that right at the beginning of that video. Nothing since been going on of note. Oh, it looks like one might be kicking off in the northwest. So that one actually could have an earthly directed component there. I see some movement on the Earth-facing portion of the solar disk. We'll cover it here in a minute. First, let's take a look at LASCO C2 and C3. Our Lagrangian point 1 coronagraphs on the SOHO spacecraft, and we'll zoom in a little bit here. And let's bring these back. So there is that CME out of the... It occurred in the northeast. It actually ejected to the east mainly. And there was an M-class flare associated with that. But more importantly, right there up in the northwest, you can see a CME popping off. Right at the end, right here on the C2. And that might be another earthly directed CME. So if it is, we can expect that one to arrive late in the day on October 5th. I'm sorry. On October 6th. Yeah, October 6th. I can do math. Anyway, we'll also show stereo A, as we got some great difference imagery here of that CME from yesterday. Here's some great imagery of that as it slowly leaves the sun's atmosphere. Anyway, we've got some custom coronagraphs here as well before we move on to filaments. So let's check those out. There's a 24-hour video featuring the Proba 2 swap instrument, Soho Lasco C2 and C3. And let's get a little closer here. So there's that M-class flare right from this region here. Right in there. And then you see that coronal mass ejection there popping off, not likely to have any earthly directed components. So let's go to filaments next. And again, check it out. We have some legit filaments, especially this one right here. That filament there is absolutely massive. And it's moving right into the Earth-facing portion of the solar disk there. And it's right in between the two most significant solar flare-producing sunspots. One right to its east or left, and one right to its south or below it on that imagery. It is certainly a coronal mass ejection watch of the Earth-directed variety. So, I mean, look at the size of that filament. Not even fully sure where it ends. It looks like it ends right up here. An absolutely massive plasma filament there. Look at the size of that thing. One of the largest we've ever covered on the channel, and we've been doing it for over 6 years. So there is definitely a coronal mass ejection watch in effect. And several other massive filaments as well on the solar disk. Let's take a look at the grayscale imagery as well, as it shows prominences. And if you're a new viewer, prominences are just solar filaments that hang off the edge, like these up here. And those prominences are an indication that there is another active sunspot rising in the northeast. And I think there's one down here in the southeast as well. So look for about 2 new sunspots at least to rise over that eastern solar limb. And that solar filament definitely could use a name. Again, look at the size of that thing. That is a big one. And if that ejects directly toward Earth, that could cause a major geomagnetic storm. By the way, if you want to name filaments after living people, do it over on Twitter. Thanks to our new Twitter followers. And by the way, why do people keep claiming that Elon Musk is a free speech advocate? He's maintained censorship on the Twitter platform. He said it himself right in a tweet. You can go read it if you want to go through 10 trillion tweets. Freedom of speech, not freedom of reach. In other words, your tweets are deboosted. You're shadow banned. That's censorship. Okay? Censorship is not freedom of speech, folks. I don't know. It's a ridiculous cult. The Elon cult is really sickening and ridiculous. It's just, I don't understand it. It's quite pathetic. Quite pathetic. Censorship is not fixed on the internet. Censorship continues. Deboosting, shadow bans, it still continues. And by the way, censorship is probably the largest problem facing mankind at the moment. Censorship ought to be dead. Centralization's already dead. And zombie corporations with nobody at the wheel are no match for people like you. Once again, thanks to our new Twitter followers. Congratulations on realizing the Twitter account exists. We've had it since 2019, and we've got over 22,000 tweets and daily original content. Less than 500 followers. How ridiculous is that? Oh, yeah. So, cheers. So here are the past couple of hours, and check it out. It looks like we have some activity right here. So that could be an earthly directed CME happening as we create the video, because we do see some ejecta coming out of the coronagraph already. Right in this area is looking like where that came from. So fingers crossed for another earth directed CME, we're hoping. And this is our pre-bonus feature segment. That is the past couple of hours from the GO 16 SUVI. So it looks like we may have another coronal mass ejection here showing up sometime late in the day on October 6th. So it looks like 2 new coronal mass ejections are headed our way. Again, fingers crossed for that, and let's get to our bonus features segment. First, on the satellite's community dashboard, no satellite charging hazards. It's smooth sailing for satellites there. No high energy or low energy electrons building up on or in satellites. The GOES electron flux here remains at sort of normal levels. We're not seeing a huge dip in that, an indication that no coronal hole high-speed stream has showed up yet. GOES electron flux there just in a normal range. There's the 1-year graph to contextualize that for you. Just kind of right in the middle portion of the relativistic electron flux. NOAA is forecasting flatlined electron flux. If we do see a coronal hole high-speed stream show up, you can expect a dip in those greater than or equal to 2 mega electron volt electrons measured at the F layer of the ionosphere. There is a diagram of the layers of the atmosphere. The F layer is where that is measured using radiography from those geosynchronous satellites. The F layer is at about 300 kilometers of altitude, and here it is in vibrational frequency. It's the bridge between Earth and space, and it's looking totally normal. If you were hoping for a civilizational collapse as a result of space weather, it's not happening. Mankind doesn't need nature. Mankind can self-destruct just fine all by itself. As you may have seen for the past about 44 months. Anyway, here's the anomalygram of the ionosphere, depicting anomaly in megahertz from a 30-day median. And again, things are quite calm and quite normal. There's nothing spooky going on. So again, if you were hoping that Nibiru would show up on the ionosphere somehow, or something like that, sorry, it's just not there. No indication of the apocalypse. Yeah, anyway, here's the latest image. That's 10:45 universal time for the ionogram, the raw vibrational frequency, and there is the anomaly in megahertz at 10:45 universal time. Next is our global ionosphere nowcast. It shows the maximum usable frequency, anomaly, and total electron contents. Hopefully that doesn't spook you either. And now we're going to just show electron content by itself. Total electron content is the most likely place you'll see GPS errors. It depicts literally a count of electrons from about 12,500 miles, the inner portion of the outer Van Allen belt, down to ground level. That satellite must communicate through the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, sometimes, especially at noontime around the equator, the inner plasmasphere, and the ionosphere. Those electrons cause signal refraction. And there is the total electron content forecast. Again, things looking quite normally there for electron counts. No anomalies of note. Here's the anomaly from the 10-day average over North America, and things are looking pretty chill as far as that goes as well. We typically end our space weather segment with the latest imagery of the closest star. There it is. And there is the magnetogram. Again, no major changes happening in the past 24 hours. However, again, we do expect to see some new sunspots rising there over the eastern limb. Which brings us to meteorology. And we're starting out today with sea surface temperature and ocean currents. So there you go. Interestingly enough, the North American continent is largely surrounded here by anomalously cold water. You see cold water up the east and west coasts. The Great Lakes are slightly on the anomalously warm side. There has indeed been a heat wave around there, so that kind of makes sense. And the North Atlantic is mostly anomalously warm water. So this depicts sea surface temperature anomaly in color gradation, as well as the currents there, ocean currents there in the animation portion of that. And guess what? The Gulf Stream, it's still warming Europe. Yep, you can see it's still up here, still making its way to Ireland and Iceland, still not creating a year without a summer in Europe. If you were banking on that, that's some bad banking. Anyway, there's a sea surface temperature anomaly and currents for the Atlantic Ocean. Southern portion anomalously cold as spring strikes, and the northern portion anomalously warm as autumn strikes. There's the Arctic Ocean. There is the Indian Ocean. Let's don't forget the Southern Ocean. And like North America, Greenland is beset on all sides by cold water. Last but not least, the world's largest body of water and largest surface heat sink, the Pacific, which is quite anomalously warm in the northern portion and around the equatorial region, and anomalously cold south of the equator. That is what's going on in terms of ocean currents and sea surface temperature anomaly. If those facts were too controversial for you, we apologize. Press the like button anyway. Anyway, now moving to regular weather stuff as we zoom into lower 48. There are the surface winds of the eastern world, and looks like that typhoon has moved a little bit closer to Taiwan there. And it also has intensified a little bit since yesterday. We're seeing at least hurricane force winds there. It's probably more like 100 miles an hour based on the way that looks. So those are the surface winds of the east side. Shout out to our viewers from the east side. Here are the jet streams from the east side. Jet streams of the central world. That's Europe, Africa, and the Middle East. Surface winds. Surface winds of the west. And the jet streams of this side of the planet. You can see that jet stream dipping way down as we forecasted a few days ago, bringing some quite cold air quite deep into the U.S. So let's check our snow depth forecast. That's not a forecast, that's actually the current snow depth situation. And let's actually take a look at new snow here. Why not? Let's take a look at new snow. So this actually is a forecast. This is the current snow depth. And there is new snow for the next, let's see, here's the next 12 hours, first of all. There's new snow for the next 24 hours. And there's new snow for the next 3 days. We won't go beyond 3 days because we like accurate forecasting. And humans are not able to forecast the weather for more than about 3 days. Why? Because of insufficient variables. Like all models, folks. Weather models are garbage in and garbage out. If you don't have the right inputs, you get garbage outputs, period. Garbage in, garbage out. It's an old programming term. GIGO, garbage in, garbage out. Tell your friends and foes about it. Anyway, there's the snow depth situation for the northern hemisphere. And let's take a look at clouds and fog. Clouds and fog for the Americas. It's too dark for the visible satellite, so this is the shortwave radiation satellite. It shows clouds and fog even at nighttime. We do indeed have a bank of clouds there moving toward the Mississippi Valley. Next, our weather.gov map. We've got some hard freeze warnings and some winter weather advisories in portions of Colorado and Wyoming especially. The Rockies Also some gale warnings there around the Gulf Coast and around the Floridian coast. If your location's lit, head to weather.gov and click it. Those are too many counties to cover. And let's take a look at our forecast here from Tropical Tidbits. So today we're going to show the GFS temperature anomaly forecast for the next 72 hours, as we've got a straight-up heat wave going on in the mid-Atlantic states. As a cold snap moves from west to east, propelled by the jet stream. That is a 72-hour GFS temperature anomaly forecast in degrees Celsius. Heat wave to continue here, especially in the eastern U.S., as that cold air moves closer and closer to the Great Lakes. We've also got pressure and precipitation based on the same GFS 72-hour model, and I would once again note those strong storms coming to Oklahoma, as well as South Dakota and Nebraska. Also some snow coming to the northern Rockies. 72-hour GFS pressure and precipitation forecast from tropicaltidbits.com. Next, our lightning. That's the past about 10 hours. And remember, folks, lightning strikes twice. Don't assume lightning's not going to strike a given spot because you saw lightning strike there. That ain't the way it works. What if there's a magnetite deposit where you saw the lightning strike? Current lightning is quite high here on a planetary scale. 805 strikes per minute there. So quite a bit of lightning in the Middle East, Mexico, and other portions of North America. Lightningmaps.org, it's highly recommended. And guess what? Lightning does strike twice on our merch because it's just awesome. If you haven't seen any of the merch, well, check it out. Today's featured product is our top seller. It's a public service message brought to you at massive personal risk and expense by Smash Staff and I. So, if you're going through hell, keep going. If you're going on a volcanic vacation, leave your vault pole at home. And whatever you do not pole vault the caldera. This handsome design features Steve Stimpak pole vaulting a volcano. But don't do it, folks. It's not good for the kids. Don't become part of the lithosphere and pole vault yourself into a volcanic caldera. It's got the homepage, smashomash.com, as well as the YouTube URL right on there. Tell your friends and foes about the merch. That is, again, our top seller. Many people have picked up Do Not Pole Vault the Caldera merch. Have you? Today's featured products from Hemp Lucid are all of them. Links below the video to the Hemp Lucid shop as well. Help support the channel via our paid affiliate/sponsor links. Help keep these videos existent, publicly visible, and free for all to view by picking up some of your Hemp Lucid products, whether they're CBD for your pets, body balms, stress stacks, immune stacks, sleep stacks, mushroom gummies, and your top seller, the basic CBDs, again from Hemp Lucid. Links below the video as well as on the homepage. And whatever you do, folks, don't go to the grocery store and buy onion powder in these little tiny jars where you're paying like $50 an ounce for it. Don't do that. Why not pick up a giant bulk thing of onion powder for $12.29? That's a 22-ounce jar there of onion powder for $12.29. So yeah, don't overpay for your spices. Pick them up in bulk and fill up smaller, more convenient jars at home instead of buying those incredibly overpriced spice jars at the grocery store. Amazon.com/shop/smashomash is another way to support the channel and save a bunch of cash. Pick up your spaceware, your spices, perhaps your organic coffee. Have you switched to organic coffee yet? Have you started buying bulk spices? I mean, don't you want to save money? Do you own an air fryer yet? You can get one of those at amazon.com/shop/smashomash. Once again, you can find all the links below this video in the description, as well as on our homepage at smashomash.com. Welcome to the Neo Renaissance. In 2018, a crack YouTube unit was sent to social media prison for a crime we did not commit. We promptly escaped a maximum security social media stockade to the internet underground, where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash team. Maybe the Smash Team has been shadow banned on social media. So become a member of the Smash Team and get email alerts, even at the bronze level. There's a bronze, there's a silver, there's a gold annual paid up subscription, which is the best value. It's almost like getting 4 months of a Smash Team membership for free. So go join over there, smashomash.com/Smash Team. These videos are brought to you in part by our gold and silver Smash Team members, as well as by Smash staff and I, again at massive personal risk and expense. So help keep the videos existent by doing things like pressing the like button, the share button. Leave us a comment, especially if you're mad about something that we've said. Maybe you're mad about all the facts that have been stated in the video, or the accurate forecasting. I know accurate forecasting makes people very angry, so terribly sorry about all the facts and accurate forecasting. Ooh, so sorry. Anyway, we're going to close out today's video with the latest Doppler, where we've got some severe storms here crossing the U.S.-Canadian border at North Dakota. So there are the strongest storms in the U.S. We will zoom out to the lower 48 view. There is the full U.S. Doppler radar map. There is clouds and fog, depicted by shortwave radiation, 3.9 micrometer infrared radiation, if you must know. It's part of the NASA GOES Interactive Weather Satellite Suite. And there is the water vapor map. So we've got a great example here of, we've got a pulse of dry massive air coming from the south. And we've got another pulse of cold massive air coming from the north, causing compression. We've also got a sort of a blocking feature over here, which this stuff is going to eventually collide with, this relative low. All that moist air. Yeah, moist air. It's less massive than dry air. Did you know this? Anyway, here's your recap. Vertical motion of the air column depicted by ground-based Doppler radar systems. Space-based systems depicting clouds and fog even when it's dark. Space-based systems depicting the water vapor, as in all of it, showing you dry as well as moist skies. Anyway, thanks for tuning into the Smash News Network, least busted name in news. We're frankly surprised that you've found that it exists with the state of affairs on social media nowadays. Anyway, we'll see you soon. And in the meantime, may that solar wind be at your back.